What is up, YouTube? Woo! Mr. King coming live, not from the studio, from the classroom today. Yes, that's right. I am back, better than ever. All right, here are the questions for the day. Please pause the video now and answer them. And yes, they did recreate the Nasty Patty from SpongeBob. And number 3 and 4 will be a little tricky. I'll give you a hint. Look at sulfur. Look at sulfur. So you may have noticed that sulfur, while oxygen has 2, 4, 6, and 8. Oxygen's good here, and oxygen has 2, 4, 6, and 8. Oxygen's good here. Sulfur only has 2, 4, and 6. And if you counted, you may have noticed that sulfur did not use all 18 valence electrons. It used 2, 4, 6, 8, 10, 12, 14, 16. But sulfur has 18, so you can add an additional lone pair on sulfur to make it have 18, and so sulfur can finally have the full 2, 4, 6, 8 octet. So that was the misconception there. Next, we are going to continue with our practice today. So when you're ready, can you go to Monday, available on practice. And a lot of students have been struggling, so I'm going to go over some misconceptions today. The first one I want to go over is hydrogen. A lot of people have been doing something wrong with hydrogens. I'm going to start with CH4. So CH4, you need to put the central atom, the C, in the middle. And the first step is always to attach single bonds from the central atom to the other atoms. And I know it's a little hard doing it on slides, but you know, COVID, we make the best of what we can. So let's say you'll do stuff like this. You attach C to the central atom to the rest of the atoms, and hydrogen is happy with 2. So whenever hydrogen has a bond to it, it's full. And a lot of people have been putting lone pairs and dots on H, and they shouldn't. H will never have a lone pair or a dot in Lewis diagrams. It'll never happen because hydrogens always have bonds, so they'll always be full with just a bond. So never have a lone pair on an H. Once an H has a bond, which it always will, it's done. You don't put any lone pairs on it, you'll have to find other places to put lone pairs on. So please be careful of that. H's will only have bonds. They'll never have lone pairs because they are the exception to the rule. They are full at 2. Next, I did want to go over the toughest one. Please pause the video now and try and do sulfur dioxide yourself. Okay, so remember, step 1, use the periodic table to determine how many valence electrons each atom has and add them up. So we're going to look for sulfur and oxygen. Remember, the column determines how many valence electrons. Let's start on this side. This column has 8, this column has 7, then this column has 6. So O and S are in the same column, they both have 6. So sulfur has 6 valence electrons, oxygen has 6, and there's 2. And since there's 2 oxygen, there's 12, because each oxygen gives 6. And there's a 2 attached to the O, so you know there's 2. So total, adding them all up, you get 6 from the S and 12 from the 2 O's. You get 18 valence electrons total. Okay, so keep that number 18 in mind. Next, you're going to put the central atom in the center, sulfur. Sulfur is the one that's alone, so sulfur is going to go in the center. Next, step 3, draw in single bonds from the central atom to the remaining atoms. So I'm going to grab some bonds, give it to sulfur, from sulfur to oxygen, and the other sulfur to oxygen. This is what you always do. You always start by connecting the atoms to the central one. Next, put in remaining electrons as lone pairs. So we have 18 total, and we just used 2, 4. So we used 4 total because each bond has 2. So we just used 4 and we have 18. So that leaves us with 14 left. So I'm going to start putting lone pairs on these atoms. I'm going to try and use all 14. And I did not give you enough lone pairs, so you do have to copy and paste to make it work. Try and get them all spread out and get them all the octets that they need. So right now I'm just going to count and see how much progress I've made. I have 18 total, and I've used 2, 4, 6, 8, 10, 12, 14, 16. Okay, I need 2 more. Copy and paste these guys. Okay, now I just used all 18. However, you should notice there's a problem. Pause the video now and try and think, what is the problem with this molecule? Just like the bell work, you should have noticed that sulfur does not have a full octet. The oxygens have 8 because they get 2, 4, 6, and then 8, but the sulfur only has 2, 4, and 6. So remember, now we have to go to step 5, where we have to give every atom an octet or duet by turning lone pairs into double or triple bonds as needed. This is a situation, it does call for it. So you're going to turn this lone pair from either oxygen to a double bond. So hypothetically, this lone pair will move and go into this double bond because they need it. But you won't actually put the lone pair there. The lone pair will become a double bond. It could be either oxygen. I just picked the one on the right. So now I'm going to check that I used all 18 and that everyone has an octet. So I used 2, 4, 6, 8, 10, 12, 14, 16, 18. And now oxygen has 4 from here, 6, 8. Sulfur has 4 from here, 6, 8. And then oxygen has 6 from lone pairs and 2 from the bond. That is the final answer for sulfur dioxide. Yep, that one was a little tricky. That's why that was the last one. Thank you everyone for watching me the entire time. Last thing, please go to Tuesday and check your grade and take the survey. After you take the survey and hit turn in for Monday and Tuesday, you're all good to go. Thank you so much. Bye.